region. Compare this temperature to those of Wichita, Kansas, on the same 37-degree north latitude line. Analysis. How did the size and shape of the light beam change as you directed the light towards higher latitudes? How does Earth teeth after the solar radiation receive by different latitudes? Physics integration. When air rises over a mountain, the air expands and its temperature decreases, causing water vapor to condense and form rain. Temperature changes caused by air expanding or contracting also occur in some machines. Why does the air coming out of a bicycle pump feels cold? Ocean currents. Ocean currents affect coastal climates. Warm currents begin near the equator and flow towards higher latitudes. Warming the land region they pass. When the current cools off and flows back towards the equator, they cool the air and climate of nearby land. How do ocean currents affect climate? Winds blowing from the sea are often moister than those blowing from the land. Therefore, some coastal areas have wetter climates than places farther inland. Look at the northwest coast of the United States shown in Figure 2. The large amount of precipitation in Washington, Oregon, and Northern California can be explained by the moist ocean air. Mountains. At the same latitudes, the climate is colder in the mountains than at sea level. When radiation from the sun is absorbed by Earth's surface, it hits the land. Heat from Earth then warms the atmosphere. In the mountain, the air has fewer molecules to absorb this heat. This is because Earth's atmosphere gets thinner at higher altitudes. Problem-solving activities. How do large cities influence temperature? The temperature of rural areas surrounding a large city can differ from the temperature in the city. Downtown by several degrees. This difference in temperature is called the heat island effect. It is partly a result of the land in cities being covered with buildings, roads, and pavements, while rural areas have gone far more open space and vegetation. Do you think the heat island effect can change as a city grows? Use your ability to interpret data to find out. Identifying the problem. The table lists the average summer high temperatures in and around a large metropolitan city. In 1978 and 1993, by examining the data, can you tell if the heat island effect has changed over time? Solving the problem. What distances from downtown experience the greatest and smallest temperature change between 1978 and 1993? Can you account for the difference? Suppose that in 1999, the average temperature in the downtown area was 36 degrees, but the temperature 24 kilometers away was 33 degrees. Would you expect this? Explain. The windward side of a large mountain range, the side facing the wind, often receives high precipitation. B. Deserts are common on the leeward sides, the sides away from the wind of mountain ranges. Rain shadows. Mountains also affect regional climates, as shown in Figure 3. On the windward side of a mountain range, air rises, cools, and drops in moisture. On the leeward side of a mountain range, air descends, heats up, and dries the land. Deserts are common behind mountains. Cities. Large cities affect local climate. Streets, parking lots, and buildings heat up, in turn heating the air. Air pollution traps this heat, creating what is known as the heat island effect. Temperature in a city can be 5 degrees higher than in surrounding rural areas. Large mountain ranges can affect climate by forcing air to rise over the windward sides and to descend on the leeward sides. How can this cause the two sides of the Sierra Nevada mountain range to be so different? Climate types. Classifying climates. What is the climate like where you live? Would you call it warm? Or different, depending on the time of the year? How would you classify the climate in your region? Life is full of familiar classification system. Classification helps to organize your thoughts and to make your life more efficient. That's why Earth climates also are classified and are organized into the various types that exist. Climatologists, people who study climate, usually use a system developed in 1918 by Vladimir Kopens to classify climates. By using the temperature and precipitation of region that had different plant types. The climate classification shows in Figure 5 separate climates into groups. Climates. It varies around the world. And as Copen observed, the type of climate that exists in an area determines the vegetation found there. Fig trees ain't found in desert. No, are cactus found in rainforests. In fact, all organisms are best suited for certain climates. Organisms are adapted to the environment. An adaptation is any structure or behavior that helps an organism survive in its environment. Adaptations are inherited. They develop in a population over a period of time. Once adapted to a particular climate, organisms may not be able to survive other climates. Structural adaptations. Some organisms have body structure that help them survive in certain climates. The fur of mammals is really hair that insulate them from cold temperatures. A cactus has a thick fleshy stem. These structural adaptations help a cactus hold water. The waxy stem covering prevent water inside the cactus from evaporating. Organisms have body structure that help them survive in certain climates. This map shows a climate classification system similar to one developed by Köppen. What pattern can you see? Behavioral adaptation. Some organisms displays behavioral adaptations that helps them survive in a particular climate. For example, rodents and certain other mammals undergo a period reduced activities in winter called hibernation. During hibernation, body temperatures drop and body processes are reduced to a minimum. Some of the factors thought to trigger hibernation include cooler temperatures, shorter days, and lack of adequate food. The length of time that an animal hibernates varies depending on the particular species of animal and the environmental conditions. Other animals have adapted differently during cold weathers. B. Cluster together in a tight ball to conserve heat. On hot sunny days, desert snake hide under rocks. At night, when it's colder or cooler, the skeleton acts in search of food. Instead of drinking water, as turtles and leaders do in wetland, desert turtles and lizards obtain the moisture they need from their food. Some behavioral patterns are shown in figure 6. Organisms have structural and behavioral adaptations that help them survive certain climates. A. Hibernating. These hibernating bats have adapted their behavior to survive the winter. B. The needles and wax skin of a cactus are structural adaptation to a desert climate. How do this adaptation help cactus conserve water? Polar bear. Polar bear have structural adaptation to keep them warm. The hairs of their fur trap air and heat. Lungfish. Lungfish survive long period of intense heat and drought by going into an inactive state called estivation. During the dry season, when water evaporates, lungfish dig into the mud and coil up in a small chamber they make at the lake bottom. During the wet season, lungfish re-emerge to live in small lake and pool. What other estivation? Lungfish shown in figure 7 survives period of intense heat by entering an inactive state called estivation. As the weather gets hot and evaporates, the lungfish burrows into the mud and covers itself in a leathery mixture of mud and mucus. It lives this way until the warm, dry months pass. Like other organisms, you have adaptations that help you adapt to the climate. In hot weather, your sweat gland releases water onto your skin. The water evaporates, taking the heat with it. As a result, you become cooler. In cold weather, you may shiver to help your body stay warm. When you shiver, the rapid muscle movements, produce heat. What other adaptations do climate give to people? How can climate be classified? What type of climate do you live in? Forming hypothesis. Climate changes. Earth seasons. Interpret zones. You can play softball. Under the summer with your you can play softball with the seasons that are short. You can play softball with the seasons that are short and the period of climate that change. Shows Earth revolving around the sun. Because the Earth is tilted, however, they do experience latitude or temperate zone. You have warm summer and cool winter. Springs and fall are usually mild. My phone. What are seasons like in the tropics? During autumn and spring, neither pole is tilted towards the sun. What are the seasons like in the tropics? The middle latitude are temperate zone and they have warm summer and cool winters. Spring and fall are usually mild. High latitudes. During the year, the high latitudes near the pole have great difference in temperature and number of daylight hours, as shown in figure 8. During summer, in the northern hemisphere, the North Pole is tilted towards the south. Sun doesn't set for the nearly 6 months. During that same time, the sun never rises at the South Pole. At the equator, days are about the same length all year long. California was plowed by large storm. El Nino can affect weather pattern. It can also involve tropical Pacific Ocean and the atmosphere during normal years. Strong trade winds that blow east to east along the equator push warm surface water towards the western Pacific Ocean. Cold, deep water then is forced up from below along the coast of South America. During El Nino years, these winds weaken and sometimes reverse. The changes in the wind allows warm tropical water in the upper layer of the Pacific. It's going to close. It's closing now. These changes. Give me, make I do one. Give me now, do me phone. This changes the atmosphere and the pressure of California. And the wind and precipitation pattern around the world. This can cause droughts in Australia and Africa. During the Pacific, the water in the eastern Pacific near Peru is cooler than normal. La Nina may cause droughts in the southern United States and excess rainfall in the northern United States. Modeling El Nino. Procedure. During El Nino, trade winds blowing across the Pacific Ocean from east to west slacken or even reverse surface water, move back towards the coast of Peru. Add warm water to a 9-in-by-13 in baking pan until it is 2/3 full. Place the pan on a smooth countertop. Blow as hard as you can across the surface of the water along the length of the pan. Next, blow with less force, then blow in the opposite direction. What happened to the water as you blew across its surface? Explain. Visualizing El Nino and La Nina. Weather in the United States can be affected by changes. Thousands of kilometers away, out in the middle of the Pacific Ocean, periodic warming and cooling of a huge mass of seawater phenomenon known as El Nino and El Nina, respectively, can impact water during normal years, right? When neither El Nino nor La Nina is in effect, strong wind tend to keep warm surface water contained in the western Pacific, while cooler water wells up to the surface in the eastern Pacific. During El Nino years, wind blowing western weaken and may even reverse. La Nina. During La Nina years, stronger than normal wind push warm Pacific waters farther west, bringing cooler and often drier weather to many parts of the United States. Sun warmed surface water spanned the Pacific Ocean during El Nino years. Heavy rain in California resulting from El Nino can lead to landslide. Resulting from El Nino can lead to landslide. This abandoned house in Laguna Niguel, California, took a right downhill during the El Nino storm in 1998. During a typical La Nina year, warm ocean water, clouds, and moisture are pushed away from North America. A weaker jet stream often bring cooler weather to the northern part of the continent, and hot, dry weather to the southern area. Climate change. If you were exploring in Antarctica near Earth's South Pole and found a 3 million year old fossil, you might conclude that the climate of that region changed because Antarctica is much too cold for similar plants. Sediment in many parts of the world shows that at several different times in the past 2 million years, El Nino glaciers covered large different times in 2 million years. Glaciers cover a large part of Earth's surface. Like any show lasting during the last ice age, colder time change quickly to warmer spell. What causes climate change? Climate change has many varied causes. These causes of climate change can operate over a short period of time. Very long period of time, Catastrophic events, including meteorites, collision, large volcanic eruptions, can affect climate. Another factor that can alter Earth's climate is short or long-term changes in solar output. When or long-term changes, which is the amount of energy given off by the sun, changes in Earth movement in space affect climate. Over many thousands of years, a movement of Earth's crustal plates can change climate over millions of years. All of these things can work separately or together to alter Earth's climate. Atmospheric solid and liquids. Small solid and liquid particles always are present in Earth's atmosphere. These particles can enter the atmosphere naturally or be added to the atmosphere by humans. Humans add particles to the atmosphere through automobile exhaust, smokestack emission. These small particles can affect climate. Catastrophic events such as meteorite collision and volcanic eruption put enormous volume of dust, ash, and other particles into the atmosphere. The particles block so much solar radiation that they can cool the planet. These particles, it shows how a major volcanic eruption affected Earth's atmosphere. In cities, particles put into the atmosphere as pollution can change the local climate. These particles can increase the amount of cloud cover downwind of the city. Some studies have even suggested that rainfall amounts can be reduced in this area. This may happen because many small cloud droplets forms rather than larger droplets that can that could that could produce rain. Energy from the sun. Solar radiation provides Earth's energy. If the amplitude of the radiation from the sun varies, Earth's climate could change. Some changes in the amount of energy given off by the sun may seem to be related to the presence of sunspots. Sunspots are dark spots on the surface of the sun. Warning. Never look directly at the sun. Evidence supporting the link between sunspots and climate include an extremely cold period in Europe between 1645 and 1715. During this time, very few sunspots appeared on the sun. Mount Pinatubo in the Philippines. During the eruption, in 1991, particles were spread high into the atmosphere and cycled the globe. Health integration. Atmospheric particles produced as pollution can affect human health as well as climate. These particles, often called particulates, can enter the lungs and cause tissue damage. People who have existing lung issues lung issues of heart problem are affected most seriously. Do your research to find out What type of law have been written to reduce particulate pollution? Earth movement. Another explanation for some climate change for some people. Earth axis currently is tilted 23.5 degrees from perpendicular to the plane of its orbit around the sun. In the past, this tilt has reduced. It has decreased to 21.5 degrees. When this tilt is at its maximum, the change between summer and winter is probably greater. Now, some scientists hypothesize that the change in the tilt affects climate. But then, two additional Earth movements also cause climate change. Earth axis wobbles in space. Just like the axis of a top wobbles when it begins to spin more slowly. Now, this can affect the amount of solar the shape of Earth orbit changes over a 100,000 year cycle. Amount of solar energy. These movements of Earth causes the amount of solar energy to vary over time, as shown. These changes might have caused glaciers to grow and shrink over the last few millions. Now, however, they do not explain why glaciers have occurred so rarely over a long span of geologic time. These changes might have caused glaciers to grow and shrink. However, they do not explain why glaciers occurred so rarely. Coastal plate movement. Another explanation for major climate change over ten or hundred of millions of years concern the movement of Earth's crustal plate, the movement of continents and oceans affect the transfer of heat on Earth. The movement as it is which in turn affect wind and precipitation. One example of time is authored, as we have learned, many theories attempt have in turn affect wind and precipitation. Many theories attempt to answer questions about why Earth climate has changed through the ages. You will understand. To answer this question, more study needs to be done before all the factors can affect climate will be understood. Climate changes today. Beginning in 1992, representatives from many countries have caused some people to be concerned. Based on the discussions, this subject also have appeared frequently in the headlines of newspaper. Magazines and magazines. Some people are concerned with present day warming of Earth. The greenhouse effect is a natural heating effect there are many natural greenhouse gases in the Earth's atmosphere. That occurs when certain gases in Earth's atmosphere trap it. So, we keep monitoring the effect. Yes. There are many natural gases in Earth's atmosphere. Water vapor, carbon dioxide, and methane are some, to name a few. Without these greenhouse gases, life will not be possible on Earth. Could get too warm, too cold, and will be, however, there will be high volume of carbon dioxide in the atmosphere. Earth could get too warm. High level of carbon dioxide has its atmospheric indication that this has happened on the planet Venus. Science Online. Research. Visit the Glencoe Science website at sciencegreco.com for more information about greenhouse gases effect. The sun radiation travels through Earth's atmosphere and hits the surface of the greenhouse gas. Greenhouse gases in our atmosphere trap the heat. How do you explain this? Global warming means that the average global temperature of the earth is rising. An increase in the greenhouse gases increase the greenhouse effect. It is the last it is in the last 100 years the surface temperature on Earth has increased 0.5 degrees Celsius. This may be as a result of more greenhouse gases. If Earth's average temperature continues to rise, then many glaciers would melt. The extra water level causes water to keep rising. Now, low-lying coastal areas would experience this some climate with sea level rising in some places. Some climate models show that in the future, Earth's temperature would increase faster than they have in the last 100 years. Some climate models shows that in the future, next you will learn how human activities may add to global warming, and you'll find out what you can do to help decrease the problem. Now, these glasses in Greenland might have receded from its previous position because of global warming. The pile of sediment in front shows how far we can reach the glacier. When forests are cleared or burned, carbon dioxide levels increase in the atmosphere. And people can help reduce. What can people do to help reduce O2 in the atmosphere? How to reduce CO2. What can you do to help reduce the amount of carbon dioxide in the atmosphere? Conserving energy or conserving electricity is one of them. When you conserve electricity, you can reduce the amount of fossil fuel that is burned. If possible, one has to meet the need and energy as shown. Another way to reduce CO2 is to plant vegetation from the atmosphere. Carbon dioxide. Plants remove carbon dioxide from the atmosphere. As you have learned, correctly planted vegetation can shelter homes from cold wind or blazing sun and reduce use of electricity. As you learned, wind, sun, and cold can be reduced. How is earth-treated houses responsible for seasons? In what way does El what way does El Nino change the climate? What climate changes are caused by La Nina? Think critically. If Earth climate continues to warm, how might your community be affected? Skills builder effect. Do you remember climbing into the car on a warm sunny day? Why was it so hot? Inside the car, when it wasn't even hot outside. It is what we call greenhouse effect. It was hotter in the car because the car functioned like a greenhouse. What we investigate. Materials. Identical large, empty glass jar. Lead for 1 non-mercury thermometers. Goals. Safety precaution. Be careful. When you handle glass thermometers, because do not touch it. Have your teacher dispose of the glass safely. Conclude and apply. Explain why you place a thermometer between 2 jars. What was the constraint in this experiment? Which thermometer experienced greatest temperature change during your experiment? Analyze. What occurred in this experiment? How was the lead in this experiment like the greenhouse gases in the atmosphere? Infer from this experiment why you should never leave a pet inside a closed car in warm weather. Communicating your data. Give us a brief. Speech discussing your conclusions to your class. For more help, refer to the Science Skill Handbook. Microclimates. Microclimates is a localized climate that differs from the main climate of a region. Building in a city do your school create microclimates? For instance, can affect the climate of the surrounding area. What you will investigate. Does your school create the microclimate? Materials. Thermometers. Psychrometer. Paper strips or wind source. Lash can. 4 or 5. Beaker. Rain. Online paper. Alternate materials. Goals. Select, observe, identify. Under observe, temperature, wind, relative humidity, and precipitation in areas outside your school. Safety precaution. Warning: if a thermometer breaks, do not touch it. Have the teacher dispose of the glass safely. Select 4 or 5 sites and around your school building. Also, select a control site well away from the school. Attach a thermometer near each of the locations you selected. Visit each site and measure any precipitation that might have fallen. Use winds Use wind Use wind to analyze your data. Safety precaution. Select 4 or 5 sites around. Also, select a control site. Attach a thermometer to an object near each of the locations you selected. Analyze your data. To find pattern. Make separate line graph. Infer what conditions could have caused the microclimate that you identified already. Analyze. Make separate line graph for temperature, relative humidity, and precipitation for your morning and afternoon data. Make a table showing wind direction data. Conclude and apply. Why did you take why did you take weather data as a control site away from the school building? How did the control help you analyze and interpret your data? What microclimates did you identify around your school building? How did these climates differ from each other? How did they differ And number 3, inter. What conditions could have caused the microclimates that you identified? Are your microclimates similar to those that might exist in a large city? Explain. Communicating. Use your graph to make a large poster. Display your poster in the school building. For more help, refer to the Science Skill Handbook. The year there was. Mount St. Helens in Washington State erupted in May 1980. It ash cloud temporarily darkened the sky and was carried thousands of kilometers away by upper air currents. Large volcano eruption. You have seen pictures of erupting volcano. One kind of volcano sends smokes rocks and ash high into the air above the crater. Another kind of volcano erupt with fury, red hot rivers of lava, snaking down its side. Erupting volcano are nature's force. Are the mightiest, causing destruction and death. But not everyone realizes how far-reaching the destruction can be. Large volcanic eruption. This, in fact, is a major volcanic eruption, can have effects that reach around the globe. An erupting volcano can temporarily change Earth's climate. Other particles move high and into the atmosphere and are carried all the way to the earth. North Atlantic Ocean wind carried a black cloud of ash from erupting across the Pacific. The summer turns bitterly cold in those places. The most tragic result of this eruption was the death of many Kwarak people who live in western Alaska. Only a handful understand the opportunity needed to catch needed food and keep them alive. They had no opportunity to do anything else. Another year without a summer. In 1815, the eruption of Tambora on the island of Sumbawa in Indonesia is blamed for North America and Europe having the year without a summer. In 1816, once again, the planet, the blanket of acid particles, was pushed by upper level wind on the island. Only volcano that throw debris among this troposphere cause this kind of climate change. Melissa Free a researcher for the National Oceanographic and Atmosphere Administration says if debris is in the troposphere, it is taken out and dissipates more rapidly than rainfall. But says to cause climate change. The eruption has to be strong enough to push materials above the troposphere and into the stratosphere. And that's what happened when Tambora erupted, leading to a very unusual summer. Reviewing main ideas. What is climate? An area climate is the average over a long period of time, such as 30 years. Climate. The three main climate zones are tropical, polar, and temperate. Features such as ocean, mountains, and even large cities affect climates. What differences might you find in the climate on the opposite sides of this range? Section 2. Climate types. Climate can be classified by various characteristics such as temperature, precipitation, and so on. Organisms. Many organisms can survive but not all can get what is needed. Now, organisms have structural and behavioral pattern. That help them survive in particular climate. Seasons are caused by the teeth of Earth axis as Earth revolves around the sun. El Nino disrupts normal temperature and precipitation pattern around the world. How could El Nino help cause California mud flow like this one? Geological records this shows that over the past few million years, Earth climate has alternated between Ice Age and warmer period called interglaciers. The greenhouse effect occurs when certain gases trap heat in Earth's atmosphere. Humans may be contributing to global warming by producing greenhouse gases. Carbon dioxide enters the atmosphere when fossil fuel such as oil and coal are burned. How can planting vegetation like tree show here help decrease greenhouse gases in the atmosphere? To help you review the various aspects of the climate classification system, use the classified study fold we made at the beginning of the chapter. Checking concepts. The following table gives average precipitation amount for Phoenix, Arizona, make a bar graph of this data. Which climate type do you think Phoenix represents? Make a bar graph of this data. What climate type? What climate type? Do you think Phoenix represents? Do you think Phoenix represents season, precipitation, winter, precipitation, snow, refreshing 5.7. Spring 1.2. Summer 6.7. Autumn 5.9. Total 19.5. Communicating. Predicting. Forming hypothesis. A mountain glaciers. In South Africa, it's getting smaller. Concept marking. Complete the concept map using the following. Tropics 0 degree to 23.5 degree latitude. Polar temperate 23.5 degree to 66.5 degree altitude. Temperature zone. For performance, concept marking, science display, make a display illustrating illustrating different factors be sure to include detailed diagram. Present your display to the class. Test practice. The Princeton Review. The graph below shows long-term behavior. Thousands of years before present, which of these statements is true? One, Earth mean temperature has never been hotter than it is today. B, the level of CO2 has never been higher than today. C, the mean global temperature 60,000 years ago was less than today. D, the level of CO2 in the atmosphere 80,000 years ago was 280 parts per million. Which of the following statements best describe this graph? As CO2 levels have increased, as global temperature has increased, CO2 level has decreased. No relationship exists between CO2 and global temperature. Air pollution. Looking out the window of the car, you notice the bright sunshine and clear sky. But it is so bright. And clear that you can see the building of the city miles away. Although the air looked clean, the building of the city isn't. It still might be polluted. In this chapter, you learn about substances in the air that can affect your health. You will also learn What you can do to help reduce air pollution. What do you think? Science journal. Look at the picture below with a classmate. Discuss what it might be. Microbes. James. Explore activity. Some type of air pollution pollutants from power plants have car exhaust. You can react with the water in the atmosphere to produce acid. This acid can return to earth in precipitation. In this activity, you will determine if your region receives acidic precipitation. Test precipitation. 1. Collect some precipitation by placing a clean glass jar on your schoolyard before a rain or snow. 2. Bring the jar indoor. If you collect snow, let it melt. 3. Pour some of the water into a clean 100-meter beaker. Use a piece of pH paper or a computer probe to test the pH of the water. If the pH value you obtain was less than about 5.6, your region receive acid rain. If the pH it's not, then it doesn't. Observe. Write a paragraph of your science journal describing the pH of the precipitation you collected. Before you read, place a sheet of paper in front of you so the long side is at the top. Fold the paper in half from the left side to the right side and unfold. Label the left side of the paper causes of air pollution. On the right side, effects of air pollution. Unfold the sheet of paper. Before you read the chapter, draw a picture of a polluted city on the outside of your foldable as you read the chapter. List causes of air pollution on the inside of your foldable. Types and causes of air pollution. What causes air pollution? Nearly every organisms depend on gases like oxygen in Earth's atmosphere to carry out life functions. In addition to essential gases, the air you breathe also contains pollutants, which are harmful substances that contaminate the environment. Air pollution comes from human activities as well as natural events, industry, construction, power regeneration, transportation, and agriculture are a few examples of human activities that can pollute the air. Air pollution include erupting volcano that spew out ash and toxic gases. What causes air pollution? Nearly every organisms depend on gases like oxygen in Earth. Natural events that contribute to air pollution and agriculture. Near Aso, a volcano in Japan, '71. Some examples of which are shown in the air, but formed through chemical interaction in the atmosphere. Secondary pollutants are responsible for most of the brown haze, pollutants that are not released directly into the air but form through chemical reaction are secondary pollution. Smog. The term smog originally was used to describe the combination of smoke, but the smoke you see near cities form a different way. Ozone is a major component of pollution. Nature and smoke. Nature can affect the formation of smoke in many cities. Smoke is not a problem because wind disperses the pollutants that cause smoke to form. In some locations, however, landforms can add to smoke development. Mountain to the northwest and the Santa Ana Mountain to the southeast. These surrounding mountains traps air in the Los Angeles region. When nitrogen compounds are added to the air and exposed to sunlight for long period of time, smoke can develop. Pollutants from car and other sources can cause urban smoke. A temperature inversion can worsen air pollution. Cool air usually overflies. Warm air near Earth's surface. Pollutants can be carried away from their sources. During a temperature inversion, warm air overlies cold air, trapping air pollution near the ground. A temperature inversion from air pollution can worsen air pollution. Temperature inversion. Physics integration. The atmosphere can influence the formation of smoke. Normally, normally temperature in Earth lower atmosphere are warmer than warmer near the Earth's surface. However, a temperature inversion sometimes during an inversion occur. During an inversion, warm air overlies cold air, trapping the cold air near Earth's surface. A temporary inversion reduces amount of mixing in the atmosphere. How does a temperature inversion contribute to smog formation? Acid rain. Acid and bases are two terms that describe substances that is neither acidic nor basic, is neutral. The acid scale shown in figure 4 indicates how acidic or how basis a substance is. But pollution substance can cause rainwater to be even more acidic. We have 0, human stomach, lemon 2.3%, milk 6.5%, seawater 8.3%, milk of magnia 10.5%. Substances with a pH lower than 7 acids. Those with a pH higher than 7 are bases. Rainwater naturally has a pH of about 5.6. Acid rain sources. Power plants burn fuel. Like coal and oil. The lights your home to power your steering. Fuel also are burned for transportation and to heat your home. This compound rises into the atmosphere and combine with moisture in the air to form the secondary pollutants sulfuric and uric acid. Wind can carry acid long distance. The acid then can be returned to Earth's surface in precipitation. Acid rain is rain, snow, fog, and other forms of precipitation. It can also harm plants and animal life. The northern states. United States is more acidic than in other areas. Sulfur dioxide and nitrogen oxide released from Midwestern power and other sources are carried by upper wind. Blowing from a generally westerly direction. The resulting acid that form in the atmosphere eventually returned to Earth as acid rain. Many lakes in the northern eastern United States have few fish due to acid rain. The average pH of precipitation varies along the United States. Particular pollution. Particulate pollution. Air contains suspended solid particles and liquid droplets called particulate matter. Some particles, such as smoke from a fire, place, or soot in bus exhaust. Other particles, such as liquid, can form from gas, such as nitrogen, before OZ as they combine with water. Coarse and fine particles. Larger particles make up coarse particulate matter and come from vehicle traveling on unpaved roads. Construction activities and dogs picked up by wind. You can see coarse particulate matter easily. When a lot of it is in the air, but the individual size of each particle is only about 1/7 of the human hair. As shown in figure 6. Fine particles make matter in much smaller than coarse particles. Matter is much smaller than coarse particles. Late matter only about 1/4 the size of coarse particles. When the size of coarse particles and come from vehicles traveling on unpaved road. Traveling on unpaved road. Construction activities and dust pick up by wind. You can see particulate matters easily. It is only when a lot of heat is in the air, but the individual size of each particle is only about 1/7 the diameter of the human hair, as shown Fine particles are released into the air from fires, vehicles, exhaust, factories, and power plants. Particulate matter can damage plants and buildings and harm your lungs. Good. I don't even know which one is glucose. Coarse particulate matter like this house dust range from 2.5 micrometer to 10 micrometer in diameter. Fine particulate matter like this soot has a diameter less than 2.5 micrometer. Human toxin, air pollution. Comes from large factories, some small businesses and transportation. Toxic pollutants and carbon monoxide. More than 180 different substances are released into the air, and they are called toxic air pollutants because they cause or might cause cancer on other serious and or other serious human problem. Toxins, pollutants also can damage other organisms. Hair. Most of the toxic hair, some toxic hair can be released from natural events such as fires and erupting volcanoes. Concentration of carbon monoxide increases when cars are stopped in traffic. Low levels of carbon monoxide can harm people with heart disease. Carbon monoxide is poisonous at high concentration. Chlorofluorocarbon. When fossil fuel are not completely burnt, a gas called carbon monoxide forms. About 60% of this colorless, odorless gas comes from exhaust. Natural events such as fires and erupting volcanoes. Concentration of carbon monoxide increase when cars are stopped in traffic. Low levels of carbon monoxide. Carbon monoxide is poisonous at high concentration. Chlorofluorocarbons. Since the discovery in 1928, people have been using chemicals called chlorofluorocarbon, chlorofluorocarbons, or CFC, is air conditioner. In air conditioner, refrigerators, and aerosol spray. For many years, CFC were thought to be wonder compound. They don't burn. They are easy to manufacture. They ain't tossing millions of tons of CFC were manufactured and sold by the mid-1970s. In 1974, scientists F. Sherwood Rowland and Mario Molina of the University of California began to wonder where all this CFC ended up. They theorized that this compound could end up high in Earth's atmosphere and damage Earth's ozone. Major source, 24%. Human-caused toxic air pollution comes from large factories, some small businesses, and transportation. Major sources, 24%, include factories such as oil refineries, steel, mills, and chemical manufacturers. Mobile sources, 41%, include car, trucks, planes. Area sources, 35%, include small businesses such as gas stations, and dry cleaners. Energetic ray from the sun hits a CFC model. A chlorine atom breaks away. An oxygen atom hits the chlorine monoxide molecule. The oxygen atom forms an oxygen molecule from oxygen molecule of ozone. If too many ozone molecules are destroyed, harmful radiation from the sun could reach Earth. Ozone depletion. A. Energetic ray from the sun hits a CFC molecule, sun ray hitting the molecule. B. A chlorine atom breaks away. Chlorine breaks away. The chlorine atom eats an ozone molecule. N C E. The chlorine atom takes one oxygen atom to create chlorine monoxide, leaving behind one molecule of oxygen gas. An oxygen atom hits the chlorine monoxide molecule. The oxygen atom forms an oxygen molecule. The chlorine atom is free to repeat the depletion process. Oxygen atom from an oxygen molecule. The chlorine atom is free to repeat the depletion processes. One chlorine atom can destroy nearly 100,000 molecules of ozone. If it is too much, harmful radiation from the sun could reach Earth. Ozone depletion. About 20 kilometers above Earth is the ozone depletion. Earth is the ozone layer. Ozone is a molecule made up of three oxygen atoms, three molecule atoms, and three ozone layer. In the mid-1980s, a severe depletion helps the Earth's organisms by absorbing some of the sun's harmful rays. In the mid-90s, a severe depletion of ozone appeared over Antarctica. After researching, scientists discovered that CFC are able to destroy ozone molecule as shown in figure 8. Measurement taken in the upper atmosphere in 1996 shows that the level of CFC is beginning to decrease. However, scientists have still not gotten to the ozone layer. What is the difference between primary and secondary pollutants? Which pollutant can react from acid rain? What causes photochemical ozone layer depletion? What pollutants can react with water to form acid rain? What causes photochemical smog? What are the three kinds of air pollution caused by burning forests in vehicles? Your activity: particulate pollution. You know that strong wind can pick up and carry small particles such as sleet from soil. However, particles also can be carried in air from a variety of sources almost any day. In this activity, we examine particulates in the air. What do we investigate? How much particulate matter is in the air? How do factors such as particulates in the air factor into the speed, the location, and the amount of particulates? Materials: vacuum cleaner, compass, anemometer, that's local weather data source, paper confetti, heavy duty rubber bands, stereo microscope, coffee filters, hand lens, alternative materials, paper filters, by vacuum cleaners. Goals: observe particulates in the air. Relate particulate abundance to weather conditions and environment. Find out for procedure. Warning: do not use the vacuum cleaner during the rain or on a wet surface. Keep cord away from moisture. Procedure: find another location for your schoolyard where electrical power is available. Each day is for 5 days. Determine the patience, the wind, the speed. Alternately, slow and steady win the race. Alternately, the information can be obtained from a frequently updated source of weather information. Also, record other weather conditions. Wrap a large paper filters around the intake hose of a vacuum cleaner. The hose hose by tightly wrap a large paper filter around the intake hose of a vacuum cleaner. Fasten the filter to the hose by tightly wrapping it with a heavy-duty rubber band. Turn the vacuum cleaner on and let it draw air. At an angle of about 1 meter for 20 minutes. Each day you should use a different filter on each different day of your experiment. Effects of air pollution. In the United States, about 62 million people breathe unhealthy air. And at least 250,000 people suffers from pollution. Related breathing disorder. The United Nations estimate that at least 1.3 billion people around the world live with air with dangerously polluted air. The effects on your health from pollution are listed in picture below. Health effects depend on how long you are exposed to the pollutant and how much of the pollutant is in the air. For example, when the air is clear, you can breathe normally. If you breathe smoky air, it will affect you. How are you going to breathe? Young children Young children and elderly people suffer from the most pollution. With the same amount of exposure to pollutants, young children get bigger doses for their size than adults do. When a child is young, he's still developing. When a child is young, he's still developing. Because they've been exposed to pollutants for too long. Particles can lodge deep in your lungs and can damage your air sac. The deepest part of your lungs smokes and carbon monoxide. Compounds found in smokes can cause your eyes to water and stings. Long-term exposure to smoke can increase your risk for lung infection, reduce your ability for normally carbon monoxide affects your blood ability to carry oxygen. High concentration of this gas might affect your vision, your ability to concentrate, and may very well lead to death. Effect of particulates and toxin pollutants. Do you sneeze when you shake out a dusty rug? When you sneeze, you force the dust out of your respiration system. Smaller particles, however, can penetrate deep into your lungs and cause part of the lungs to be inflamed. Toxin substance. The tubes that carry air deep inside your lungs are lined with mucus producing glands and small-like structure called cilia. The cilia moves, constantly sweeping the mucus and trap particulate matters upward your throat. Every time you swallow, you begin the process of cleaning this mucus and particulate matter from your body. Cigarette smoking destroys the distillate over time. Infer what might happen to your lungs if you smoke cigarettes. Inhaling acid. When you inhale humid air from acid rain, acid can be deposited deep inside your lungs. And acid irritates the lung sensitive tissues and reduces your ability to fight respiratory infection. Your lungs are responsible for moving oxygen into your blood. Over time, the heart can become stressed and weak. Increase of ultraviolet radiation, concentrating pollutants. Acidic rain and stream. When you inhale acid from acid rain, acid can be deposited inside your lungs. Acid irritates the lung sensitive tissues and reduces your ability to fight respiratory disease. You reduce the connective tissue to 2%. Damaged lungs cannot transfer oxygen to the blood easily, so the heart must work harder to pump to every cell. Over time, the heart can become stressed and weak. Increased ultraviolet radiation. Harmful rays from sun, called ultraviolet radiation, are blocked partially by proactive ozone layer. In the known table. Over time, the heart can become weak. Increase ultraviolet radiation. Harmful ray from the sun, called ultraviolet radiation, can either be increased or reduced, all depending on you. Protective ozone layer. Each spring, an ozone hole forms over Antarctica. An ozone level falls as much as 70% below, about 90% below normal in the summer, and 10% below normal in the winter. In humans, increased ultraviolet radiation is linked to skin cancer. One type of skin cancer, malignant melanoma, shown in figure 11, accounts for only 4% of skin cancer cases, but causes about 79% of skin cancer deaths. About 47,700 people are diagnosed with malignant melanoma in the United States. In the United States each year, and nearly 7,700 people dies from it. The number of new melanomas diagnosis has more than doubled since 1973. In addition to skin cancer, cataracts are more common in people who are exposed to high amounts of ultraviolet radiation. Cataracts are more of eye damage and makes the lens of the eye cloudy. Ultraviolet radiation also can affect the immune system, which help you fight illness. What are some of the health effects of increased ultraviolet radiation? You can protect yourself against excessive ultraviolet radiation by avoiding outdoor activities during the middle of the day and by wearing your long sleeve or hat with a wide brim, sunglasses, and using your protective sunscreen. Effects on earth organisms. Animals are exposed to air organisms or to air pollutants when they inhale gases and some particles. Particles can easily penetrate. Small particles. Because air particles falls to earth in rain or snow, animals are exposed when they ingest pollutants in water and food. Just like human, thank you. Just like human, soft-blooded animals such as earthworm or animals with him moist skin such as amphibians can absorb air pollution directly through their skin. Just like human, young animals are not able to tolerate the same amount of pollution as adults can. Whether or not an animal will be affected by a pollutant is still yet to be known. Pollution and pollutants are being observed keenly. Just like human, Whether or not an animal will be affected depends on the kind of pollutant, the length of time the animal is exposed to the pollutant, and the amount of pollutant taken into the animal's body. Concentrating pollutants. The concentration of pollutants in the air might not be high enough to cause a problem. The concentration might not cause a problem, but some pollutants, however, stay in human tissue when they eat. This pollutant acts as a problem when faced with these animals. Many of these animals have been exposed to this problem for a long time. Just like humans, pollutants from the air such as metal, mercury, and pollutions from the air such as metal, mercury, can end up in high concentration in animals through biomagnification. Pollutants often are measured in parts per million. Acidic lake and stream. Recall that lower pH means higher acidity. The pH of some stream, lake, and other water body can decrease when acid rain fall. For example, 100 of lake in the Adirondack mountain can be sorted out. Acid rain is an even greater problem when snow melts. If a large amount of acidic snow falls in the winter and melts quickly in the spring, a sudden rush of acid flows into the lake and stream. Many fish and other organisms have been killed because of sudden change in pH level. Acid rain can also damage plants. At higher elevations, trees are often surrounded by fogs. When the fog is acidic, trees suffer injury and are less able to resist pests and diseases. Some stand of evergreen in the Great Smoky Mountain National Park, as shown in Figure 13, have died from acidic exposure. Acid rain Acid rain and soils. Acid rain can also affect soil. As acid rain moves through soil, it can strip away many of the nutrients that the trees and other plants need to grow. The compound in smoke affects animals and plants. Smoke affects the respiratory system of animals. The small compound in smoke affects animals and plants. When plants are exposed to smoke over a long period of time, scientists estimate that smoke forms from vehicle exhaust damages millions of dollars worth of crop in California. What effect does smoke have on plants and animals? The ozone layer. As the ozone layer thins, organisms called phytophytons live in the earth's fresh water and ocean. They make food using carbon dioxide and water in the presence of sunlight. Research shows that ultraviolet radiation might affect many agricultural crops. They make food using carbon dioxide and water. Ultraviolet radiation might affect many agricultural crops such as rice by decreasing the plant's ability to fight disease and pests. Even small increases in ultraviolet radiation might reduce the amount of rice grown per kilometer. Rice is the main food source for more than half the world population. The world population is growing, but the amount of land suitable for farming will not increase. Damage to materials and structure. Air pollution not only affects your health and the health of other organisms, it also damages many materials. For example, acid rain is known to corrode metals and deteriorate stones and paints. To reduce the damage on automobiles, some manufacturers use a special acid-resistant paint which costs millions of dollars per year.
We are moving.
Expensive cleaning. Thank you, Jesus. In cities all over the world, work of art, ornate building and status and structure like Pyramid of Egypt are shown suffer from the effect of air pollution. Solution to air pollution. History of clean air law. Between 1900 and 1970, motor vehicle use and industry manufacturing expanded rapidly in the United States. Hair in some part of the states became expensive. Air pollution became the order of the day. Scientists and government officials recognize that air quality must be protected. Beginning in 1955, the U.S. Congress passed a series of laws to help protect the air you breathe. A summary of those laws is listed in Table 1. The U.S. Environmental Protection Agency has the responsibility of gathering and analyzing air pollution data from across the country. Each state is responsible for making sure that the goal of the law are met. State agencies issue permits to power plants and industries which limit what they can release into the air. Companies that exceed air pollution limits might have to pay a fine. Automobile exhaust is monitored in some areas with poor air quality. Name of law, what it does. Air Pollution Control Act of 1955. It granted $5 million annually for air pollution research. Although it did little to prevent air pollution, the law made the public aware of pollution problem. Clean Air Act. This Air Act granted $95 million per year to states and local governments for research to create air pollution control program. It also encouraged the use of technology to reduce air pollution from car and electric power plants. Clean Air Act 1970. It set standards for specific pollutants in the air and placed strict limits on car exhaust and pollutants from new industry. This act placed strict limits on car emissions and the use of cleaner burning gasoline. It also forced companies to use best technology available to reduce toxin emission. Ambient air. You know that air pollution is released in one part of the country. You affect the air somewhere else. You also have learned that natural events such as temperature inversion can concentrate pollutants in an area. If the air you breathe does not meet standards, limits are placed on emission. Ambient air must meet air quality standards for 6 different pollutants. Air pollution law are written to help keep ambient air clean, no matter what the source of pollution is. Across the United States, scientists sample and test ambient air for particular matter. United States. As it is known in the United States that across the United States, scientists sample and test ambient air for particular matter: carbon monoxide, sulfur dioxide, nitrogen oxide, lead, and ozone. These pollutants cannot exceed a certain number of pollution. It cannot exceed a certain level called an air quality standard. Areas that already have fairly clean air, such as national parks, have strict air quality standards than cities do. If an area is polluted, has pollution level above ambient or quality standards, control can be placed on specific source of air. Of controls can be placed on that specific source of that air pollution as noticed. Controlling source. Pollutants. Pollutants. Pollutants released into the air from a particular pollutant released into the air from a particular source are called emissions. Emissions are measured as industry smokestacks and automobile tailpipes. If ambient air quality standards are not met, emissions may be released. Emissions can be controlled in two ways: by using devices that capture pollutants, already creating a way for us to reach out to our environment, or also by reaching out to people who would fight for the pollution. For example, auto exhaust used to contain many more pollutants than it does. But today, since 1975, each new car sold in the United States have since been equipped with catalytic converter. Catalytic converter, a device that changes harmful gases in car exhaust to less harmful ones. A catalytic converter and other emissions control device are shown in Figure 17. What two methods can be used to control emissions? Changing the way gasoline is produced has helped control the amount of pollutants in gasoline even before it is burned. Compounds such as alcohol can be added to gasoline to reduce tailpipe emission. Since the 1990 Clean Air Act was enacted, only clean burning gasoline can be sold in the smoggiest area of the country. Visualizing emission controls. In the past few decades, new technologies have reduced air pollution by trapping pollutants at their sources. Devices such as smoke track scrubbers, electrostatic precipitation, and catalytic converters shown here use different methods to remove pollutants from exhaust gases. Clean air, contaminated gas, sewing liquid, droplets, remove more contaminants, liquid entrance, contaminate stick to liquid droplets. As smoke enters an electrostatic precipitator, plates that line the interior, positively charged plates, then attract the particles, cleaning the smoke. An electrostatic precipitator removes up to 99% of particles matter from industrial emission, exhaust from engine, cleaned exhaust existing pipe, catalytic converter, polluted smoke, and go out here as clean smoke. Cleaned exhaust exists pipe. The metal cause chemical reaction that change most of the harmful gases into carbon dioxide and water. You can help. Law and new technologies will help reduce pollution, but you can be a part of the solution too. You can be if you want to be. When you reduce the amount of electricity you use less fuel. It'll start. Reduce the amount of electricity you use less fuel. Use less fuel. Turn off lights and all appliances when you are not using them. Open window in the summer instead of using air condition. Using public transportation, riding a bike or carpooling will keep the air clean. Car emits 0.6 grams of nitrogen oxide per kilometer. Light trucks, minivan, and sport utility vehicles can emit 1.1 gram to 1.7 gram per kilometer, depending on their sizes. How many grams of nitrogen oxide would not be emitted if you rode your bike for 5 kilometers instead of riding in a car? Calculating pollution caused by burning coal. Example of problem: sulfur dioxide or sulfur oxide. Sulfur oxide belongs to a family of gases. That are formed when coal or oil is burnt. It is considered to be major air pollutant. Burning a certain type of coal produces about 0.01 kilogram of SO2 per kilogram of coal. If a power plant burns 3 million kilograms of coal annually, how much SO2 would be released? Solution: 1. This is what you know. 2. This is what you need to find out. 3. This is the equation you need to use. 4. Substitute the known value. Production rate equals to 0.01 kilogram of SO2 per kilogram coal. Annual use: 3 million kilogram of coal Annual emissions, kilogram of SO2 produced each year. Annual emissions equals to annual use times production rate. Annual emissions will be equals to annual emissions will be equals to decent works and economic migration. If a power plant burned coal annually, how much SO will be released? Composition. You can help. Improving air quality. The total amount of air pollution released per year is big enough to sort the problem above. United States has decreased since the passage of street air pollutant policy. Improving air quality. Air quality. Air quality is that is in the United States have been improved since the emergence of air quality in the United States has been improved since 1990, even though energy use increased. Even though energy use increases, the quality of air you breathe has actually been improved. The quality of energy you use have actually been improved. Sources of pollution that have greatly decreased the quality of the air you breathe. Even so, although the national trend for most air pollutants are decreasing, others such as nitrogen dioxide continue to rise. Smog levels are increasing in many rural areas, and the United States is home to more than 2,500 bodies of water whose fish are unstable to eat because of biomagnification. As the United States population continues to increase, conservation and new technology can help reduce air pollution. Why did the air in some parts of the United States become more polluted from 1900 to 1970? Ambient air is sampled and tested. for which pollutants across the United States. Why did the 1970 Clean Air regulate? How is the air pollution reduced when energy is conserved? Researching information. Research to learn about the type of technology that they are used to help reduce pollution today, what new technology may be used in the future to help solution today, and how long can that. And then use the internet, air pollution where you live. The quality of the air you breathe can affect your health and your health of others near you. Air pollution. Air pollution is the major kind of pollution that we have. Recognize the problem. How has the community, how has quality of the air in your air been? You can also be, by visiting your community, you can determine how the changes in the law breathes. How is it how you feel if people live, and how you are feeling like everywhere is congested when people are much. Air quality can be stressed many ways. For example, you can count the number of quality per year. Let's exceed healthy value. You can see problem from this value and quality based on the way it is treated. Goals. Identify, investigate, evaluate, and identify. Identify goals that you feel are worthy of my time. Go to goals and go to goal science. I want to buy a name. Okay, which test I need to do? Clinical science website at clinical. Plan. Search for information about air quality, indications for your communities, your blood and everything. Information that can be collected by a private group. Review carefully the data you find. What information illustrates the change in your air quality during the last 20 years? Examine the data to determine trend. Review carefully the data you find. Do the trend. In the data, show a continued increase in air quality. As the air quality improve or worsen in an irregular pattern, 4. Look for other types of informations that provide additional clues about your journey. 5. For example, does your gasoline sold in your area contain clean burning additives? What makes sure your teacher approve your plan before you start? Analyze your data. Calculate your take into graph your annual data, 5 years and 10 years data. Describe the air quality changes for your area. List the additional that describe changes in your community that might affect your air quality. Overall, how would you assess the quality of your community air? Has there been a change in the air quality? What indications provide these data? Does your data support or refer to your hypothesis about air quality? Why? How do you protect yourself from something you can't see, smell, or taste? The invisible threat. Reviewing main idea. Section 1. Type and causes of air pollution. Human activities and nature can cause air pollution. What types of pollutants are released into the air? Section 3. Solution to Section 2. The Environmental Protection Agency monitors ambient from monitor ambient air for certain pollutants. No, 12. Air pollution control laws passed since. This thing is stressful, and I'm only human. This is the third day. If you can't hear me, you can just remind me, and I'll come up. Air pollution law passed since 1955 have reduced air pollution level significantly. I'm saying the same thing. I am tired and I am stressed. So you can just keep reminding me, Angel, your voice is down. Technologies such as catalytic converters on cars and scrubbers on smoke stars help reduce air pollution levels. How does adding substances to gasoline like ethanol help reduce air pollution? Animals are exposed to air pollutants when they inhale gases and particulates and ingest pollutants. Some soft-bodied organisms and amphibians also can absorb pollutants through their skin. The ozone layer protects Earth from ultraviolet radiation. What are some health effects caused by increased ultraviolet exposure? The greater the concentration of a pollutant is, the greater the length of time a person has been exposed to pollutants is. The greater the health risk is, depending on the exposure. Smoke, pain, and particulate pollution can cause manual discomfort or lead to long-term health problems. Pollutants can increase in concentration as they magnify through food chain. Section 3. Solution to air pollution. The Environment Protection Agency monitors ambient air for safety problems. Air pollution controls law passed since 1955 have reduced air pollution level significantly. Technologies such as catalytic converters on cars and scrubbers on smokes stacks help reduce an airborne. How retarding air substances to gasoline like ethanol help reduce air pollution. Visualizing main ideas. Complete the following chart on the health effects of air pollution. Air pollution. Toxic pollutants. Health effects. Skin cancer. Steam green water eyes and lung damage. Vocabulary. Using vocabulary: acid rain, ozone layer, air quality, particulate matter, standard, photochemical smog, chemical pollutant, ambient biomagnification, cataract, emission, ultramicrotoxin, air toxin, pollutants, secondary school pollutants, and all of those things. So, of course, you go back to school. Our book in there. So, using vocabulary. Use words you know about the listed term to answer the following questions. How do pollutants from photochemical smog give an example of a secondary pollutant in smog? Why are emissions controlled when ambient air doesn't meet quality control? Why didn't the ozone layer meet the air quality? Why doesn't the ozone layer meet the air quality standards? Why didn't the ozone layer immediately recover Despite restrictions of chlorofluorocarbon use in the mid-1990s, explain how sulfur dioxide emission of toxin got out. Why didn't the ozone layer? Why didn't the ozone layer? How can biomagnification? How can biomagnification of toxin air pollutant occur in the environment? Thinking critically. How can traffic jam increase air pollution? Why does air pollution affect the health of older people more than young people? Why are there air quality standards for ambient air? What are the 3 things you can help pollution do? Why is concentration on some pollutants greater in some bed than normal in a small way? Recognizing cause and effects. It has been sunny and hot with a little wind for more than a week in your city. The newspaper reported that smog levels are unhealthy, explain the connection. Converting units. Most pollutants are converting units. They are placed there because of your conversion of other units. So, how can you mention how many micro and in 1 gram? Research to find out. Research to find out. How can you mention? Research to find out. There are 1,000 micrograms in 1 milligram and 1,000 micromilligram, 1,000 milligram in 1 gram. How many microgram are in 1 gram? Comparing and contrasting. Compare and contrast the effect of acid rain and ultraviolet radiation on organisms. Researching information. Research to find out how many Antarctic organisms are affected by ozone depletion. Communicating. Illustrate how emissions from Midwestern states can cause acid rain in the northern United States. Performance assessments. Make a poster. Research the pollutants found in cigarette smoke. Make a poster of how this substance adds your health. Organize activities. To conserve energy in your school, place sign near light switch that remind people to turn off lights when they leave the room. Make sign encouraging students to carpool to school events. Please turn off all lights when you leave. Test practices. Automobile produced before the mid-1970s used leaded gasoline. Car engines have since been designed that don't require lead in gasoline. The graph below illustrated average lead emission for the United States over 20 years period. Already brought gas is just to feed gas. Lead emission 1980 to 2000 to 2000. 1980 to 2000 period. Study the graph and answer the following questions. Which of the following phases describe lead emission in 1980? A. Most came from industrial sources. Most came from transportation. Emissions were lower in 1980 than in 2000. Total emissions were 10,000 tons. Which of the following emissions is likely responsible for the reduction in emissions? Can I use unleaded gasoline? People drive less. Industry has produced more products. More electricity is produced. Student resources. Hurricane. Reading comprehension. Read the passage, then read each question that follow the passage. Recite what is said best to your understanding. Hurricane, an exchange between ocean atmosphere. Hurricanes are becoming the most on the field now. Hurricanes are becoming most feared on the screen. Hurricanes are among the most feared of all weather storms in the Atlantic region. In the Western Pacific, they are known as typhoons, and in Australia and Indian Ocean, they are called cyclones. Then, hurricane can switch. You can switch. Hurricane over Atlantic Ocean. Begin Atlantic pressure. You can switch. Wipe swift. Your nose. 27 degree to 100 degree is protected by, apart from the normal face, it is snap and sent to my iCloud. So I usually know who is with my phone at what time. To be classified as an hurricane, the king will never heard that it is an hurricane. Nobody knows that. Can I do it? Hurricane can last at least 3 days. Hurricane are Atlantic Ocean to weaken low pressure system, usually in the tropical sea west of, let me finish this one, in the potato sea west of heat from the ocean, water give the system energy. Once the water temperature rise to 27 degrees Celsius, a hurricane can form. To be classified as a hurricane, the wind speed of the storm must exceed 119 km per hour. Hurricane can last for several days and can reach heights up to 16 km above water. The Atlantic was about 10 tropical storms each year. Of these, 6 of them might develop into full-blown hurricane. Hurricane can cause severe damage to anything near them on the water. After a hurricane reaches land, it loses a source of energy, warm ocean water, and begins to weaken. Even though the strength of this storm fades as they reach shore, hurricanes frequently are responsible for billions of dollars for damage and losses of life. Which the following was described first in the passage. To classify as a hurricane, the wind speed must be more than 27 km. What is the energy source? Hurricane, wind, high wind. Reasoning and skills. Read each questions and choose the best answer. Jim and Todd noticed that some type of patio chain were not allowed to sit as others. Which of the following would be the best test of this hypothesis? Measure and record the height and weight of all the chairs. Sit on it, each one. Sit on it, each one. Sit on it and tell me the weight. Find out where each of the chair was positioned. Record the surface area of the chair. Think of what type of scientific information will be needed to answer the question conclusively. Most water vapor and gases contains the ozone layer. Foreign plants very stay there. What type of tornado occurred near this home? Light, moderate. Taking up tornado. Light, moderate. Taking up tornado before taking chimney. You don't know whether you're not taking it against. According to the table above, the ozone layer will be found at 12 Yes, it is to take up. Fourth, light, broken streets. Lights, broken window and chimneys. Moderate, rough and rough damage, considerable because of manage, considerable and very much yes. Only time. What type of tornado occur here? Awesome. Students resource. Feed. Clouds. Key to cloud classification. The following symbols are used in the first guide to represent and shape of common cloud. Shape of common cloud. Height. Describe height. Choice. Describe choice. Describe height and describe choice and describe everything. For the new horse, please help. For a quick week, use this fish. Showing the round fire is asleep. For a quick week, use this area to observe the cloud. 2 to 3 each a day in your science journal. Record the date, time. Observe the cloud. Between and types of cloud that are present. Cirrus. Frederick Cirrus cloud are the highest cloud. They are formed of ice crystals. They usually signal for weather, but they also can be a sign of changing weather. On the books of the cloud. Cirrus clouds are small, round, and white buff. They are almost. They are rifts in patterns or reassembled. The scale of fish, hence, a sky full of cirrocumulus cloud is called a mackerel sky. It's called a mackerel sky. Autostratus. Gray or blue-gray autostratus cloud. They are never white, often cover the entire sky. They are a sign of widespread steady rain ahead. Autocumulus. This puffy white or grey cloud look like rows of soft cotton balls randomly scattered. Autocumulus cloud can mean several days of fair weather. When the cloud resembles each castle, expect a thunderstorm by day end. Nimbus-stratus. Dark grey nimbus-stratus cloud are associated with or for this post precipitation. It's light, moderate, rarely heavy. Nimbus-stratus could often have streaks expand to the sky. Stratus, lowering cloud surface. Stratocolumus, low coming cumulus. The anguish from the small scattered cumulus cloud with vertical growth signal fair, whether they have dome shape or tower cloud like column. Cumulonimbus. Cumulonimbus. These are thunderstorm clouds. They form near Earth's surface and grow to nearly 15,000 meters. Lightning, thunder, and strong wind are associated with cumulonimbus cloud. Lightning. This type of lightning is characterized by a single streak of lightning connecting the cloud and the ground to a streak with one or more forks in it, occasionally a tall object. More on Earth initiative really leaders. Forcing me into an initiative is not the right now, personally for me. When storm clouds form the particles in cloud, when one another removing electronics for some adding them. Well, this is what to do. Accumulate, accumulate, then accumulate, accumulate, and accumulate. You go open. These negative charges repair reactions in the ground. Repairs reaction. The cloud becomes positively charged, even if the negatively connected is with him. They get moved downwards to a zigzag path called a steep ladder as the leader approaches the ground sponsored in Rhino page. They move downward in a group zigzag pattern. They call a steep leader. The leader has gone there and halts. The circle of leader and return. Stroke can be repeated many times. In less than a second, the lighting you see. In an hour, next thing she heard, the spirit had run away, and she heard foot galloping. And what came out astonished me today, a very beautiful white stallion. And it came straight at me, put the head on my head, and rubbed it in the nozzle. The most common type of lightning strike from one another is human being. But to not just like an animal, but to love an animal like a family member is something else. And I've not known you for long. I don't know that with people. And the cloud and the sky, to the surface surrounding here, ground to cloud hearing. This type of lightning is characterized by a single streak of lightning. During thunderstorm, observe the nurses lighting away. because I had to tell them to relax. Everybody needs to be free. And cloud to cloud lightning. Cloud to cloud lightning is the most common type of lightning. It can occur between cloud, intercloud, or the fighting is often hidden by the cloud shells themselves. Isn't there a song like that? Cloud to cloud. When there is one time you have not paid people. When a lightning stroke in the middle above crowd or anything, it causes everything bought by anybody should be brought to become lightning. Some form of lightning differs in appearance from the forked flashes commonly considered to be lightning before. Has it not covered it? And please take control. They would have seen. They would have seen what we have not shown them before. Some forms of lightning differs. Some form of lightning differs in appearance from the forked flashes commonly communicated to the lightning, however, very attractive, funny angel. For the same reason, to neutralize accumulation of charges, street lightning appears to fill a large section of the sky. It appears it's caused by light reflecting off the water droplets in a cloud. The actual stroke of lightning are far away or hidden by cloud. When the lightning is so far away that no thunder is heard, it is often called heat lightning and usually can be seen during summer nights. Ribbon lightning is a thicker flash than ordinary cloud to ground lightning. In this case, wind blows the channel that is created by the return stroke sideways because each return stroke follows this channel mode. For this channel, each is moved slightly to the side to the last stroke, making each return stroke of the flash visible, and thus wider ribbon-like band of light is produced. Ribbon lightning. Chain lightning. Chain lightning is also called bead lightning. It really is like moves like this. Part of the flash being hidden by cloud or rain. Some form of lightning are rare or poorly understood and have different appearance than the previously described forms. Spirits. Spirits are red or blue flashes of light that are sometimes one's shape and occur high above a thundercloud, 60 to 100 km above the earth. The flashes are associated with thunderstorms that cover a vast area. Spirits are estimated to occur in about 1% of all lightning strokes. Ball lightning. There have been numerous eyewitness accounts of the existence of ball lightning, which appears as a sphere of red, yellow, orange, or white light, usually between 1 centimeter to 1 meter in size. Ball lightning seems to occur during thunderstorms and appear within a few meters of the ground. The ball may move horizontally at the speed of a few meters per second or may float in the air. Ball lightning usually lasts for several seconds and may vanish either quietly or explosively. Unlike other forms of lightning, which can be seen by many observers at large distances, the small size of ball lightning and its random occurrence makes it difficult to study. As a result, the cause of ball lightning still are not known, and even its existence is disrupted. Saint Angel fire. Saint Angel fire is a bluish-green glowing light that sometimes appears during thunderstorms around or pointed like the mast of ship and lightning rod. It also occurs around the wing, the propellers of an airplane flying through thunderstorm. A size or crackling noise often accompanies the glow. Saint Angel fire is caused by the strong electric field between the bottom of a thumb, the rod, and the bottom of the ground. The electric field is strongest in round, pointed objects. If its field is strong enough, it can pull electrons. Once it collides, it's already moving. That is Saint Angel fire, and it has always been a pleasure working with her in her family, organizing informations. As you study science, you will make many observations and conduct investigation and experiments. You will also research information that is available from many sources. These activities will invoke organizing and recording data, quality of data you collect, and the way you organize it. It will determine how well others can and use it in the figure. 1. The student is obtaining and recording information using a thermometer, putting your observation in writing, and in an important way of communicating to others. The information you have found and the experiment of your investigation and experiment. Researching information. Scientists works to build on and add to human knowledge of the world before moving in a new direction. It is important to gather the information that is already known about the subject. You will look for such information in various reference resources. Follow these steps to research information on a research subject. Determine exactly what you need to know about the subject. For instance, you may want to find out what happened when Mount St. Helens erupted in 1980. Make a list of questions such as when did the eruption begin, how long did it take, what kind of materials was expected, and how much. Use multiple sources. Use multiple sources of recovery and income. Use multiple sources such as textbook, encyclopedia, government documents, professional journals, science magazines, and the internet. List where you found the sources. Make sure the sources you use are reliable and most currently, and make sure they are available. Collecting data is one way to garner information directly. Evaluating print and non-print sources. Not all sources of information are reliable. Evaluate the sources you use for information and use only those you know only those you know how to be dependable. For example, suppose you live in an area where earthquakes are coming and you want to know what you do to keep safe. You might just sit on a website and write it out. One website contains earthquake tip written by a company and that says metal scraping to help you shape in your world, and the other is a web page on earthquake safety written by the US Geological Survey. You would choose the second website as the more reliable source of information. In science, information can change rapidly. Always consult the most current sources. 1985 sources about the moon would not reflect the most recent research and findings. Interpreting with scientific illustrations. As you research a science topic, you will see drawings, diagrams, and photographs. Illustrations help you understand what you read. Some illustrations are included to help you understand an idea that you can't see easily by yourself. For example, you can't see the layers of Earth, but you can look at a diagram of earth layers as layers in figure 2 that help you understand what layers and where they are located. Visualizing a drawing help many people remember details is more easily. Illustrations also provide examples that clarify difficult concepts or give additional information about the topic you're studying. Most illustrations have a label or captions. A label or captions identifies the illustration or provide additional information to better explain it. Can you find the caption or label in figure 2? Although it is not a concept map, a Venn diagram illustrates how two subjects compare and contrast. In other words, you can see the characteristics that the subjects have in common and those that they do not. The Venn diagram in figure 3 shows the relationship between two types of rock made from the same basic chemical. Both rock share the chemical calcium carbonate. However, due to the way they are formed, one rock is the sedimentary rock, limestone, and the other is the metamorphic rock, marble. Concept marking. Concept marking is a kind of marking concept mapping. If you are taking a car by trip, you might take some sort of road map. By using a map, you begin to learn where you are in relationship to other people on the map. So a concept map is similar to a road map, but a concept map shows relationships among ideas or concepts rather than the places. It is a diagram that visually shows how concepts are related. Because a concept map shows relationship among ideas, it can make the meaning of ideas and terms clear and help you understand what you are studying. I'll be going for a 5 minutes break. Thank you very much. Network tree. Look at the network tree that shows the three main types of rocks. A network tree is a type of concept map that notice how some words are in overs while others are written across connecting lines. The words inside overs are science-themed words. Or concepts. The words written on the connecting line describes the relationship between the concepts. While constructing a network tree, write the topic on a note card or piece of paper. Write the major concept relating to that network on separate note card or piece of paper. Arrange them in order from general to specific. Branch the related concepts from the major concept and describe the relationship on the connecting lines. Continue branching to more specific concepts. Write the relationships between the concepts on the connecting lines until all concepts are mapped. Then, examine the network trees for relationships that cross branches and add them to the network tree. Student resources. Event chains. An event chain is another type of concept mark. It models the order of items, their sequence. In science, an event chain can be used to describe a sequence of events. The step in a procedure or the stages of a process. When making an event chain, first find one event that starts the chain. This event is called the initiating event. Then find the next event in the chain. Oh God. And find the event in the chain. And suppose you are asked, why sound nice? Make an echo. Make an echo. You might draw, please, God. You might draw an event such as one. God. It's the cone. You might draw an event such as the one. Notice that Connecting words are not necessary in an event chain. Yeah. Circle map. A circle concept map is a specific type of event chain map in a circle concept map. The series of events does not produce a final outcome. Does not produce a final outcome. Notice, you might draw an event chain such as the one in figure 5. Notice that connecting words are not necessary in an event chain. Cycle map. Event chains shows the order of steps in a process or event. Sun shines on Earth's surface. Surface warms. Moist air rises. Moisture condenses as air cools. Cloud forms. A cycle map. Cycle map is a specific type of event chain map. In a cycle concept map, the series of events does not stop a final outcome. Instead, the last event in the chain relates back to the beginning event. You must decide what event to be used as the beginning event. Once that is decided, your list events will occur between events that are described. Between events that are described, what happens when one event to the next? The last event in the cycle concept map relates back to the beginning event. The number of events in a cycle concept varies, but is usually 3 or 4. Look at the cycle map shown in figure 6. Nighttime ends with sunrise. Signal start of daytime. Daytime ends with sunset, and sunset signal the start of nighttime. The cycle map shows events that occurs in cycles. A type of concept map that you can use for brainstorming is a spider map. When you have a central idea of what you might find, you need to jumble ideas. A cycle map, a spider map, jumble ideas that relate to it but are not necessarily clearly related to each other. The spider map on mining in figure 7 shows that if you write this idea outside the main concept, then you can begin to separate groups and unrelated items, so they become more useful. A spider map allows you to list ideas that are related to a central topic, but not necessarily to one another. Writing a paper. You will write papers often when researching science topics or reporting the results of investigations or experiments. Scientists frequently write papers to share their data and conclusion with other scientists and the public. When writing a paper, use this step. Use the step 1. Assemble your data by using graphs, tables, or a concept map. Create an outline. Step 3. Organize the body into graph. Each paragraph should start with a topic sentence, and the remaining sentences in the paragraph should support your points. Step 4. Position data to help support your points. Step 5. Summarize the main points and finish with a conclusion statement. Step 6. Use table, graphs, charts, and illustrations whenever possible. Investigating and experimenting. You might say the work of a scientist is to solve a problem. When you decide to find out why one corner of your yard is always soggy, you are problem solving too. You might observe that the corner is lower than the surrounding area and has less vegetation growing in it. You might then decide to see whether planting some grass will keep the corner drier. Forming hypotheses. The method scientists use include identifying the questions, making observations, forming a hypothesis, testing a hypothesis, analyzing results, and drawing conclusions. Scientific investigations involve careful observations under controlled conditions. Such observation of an object or a process can suggest new and interesting questions about it. This question sometimes lead to the formation of a hypothesis. Significant informations are designed to test a hypothesis. Identifying a question. The first step in a scientific investigation or experiment is to identify a question to be answered or a problem to be solved. You might be interested in knowing why a rock like the one in figure 8 looks the way it does. When you find a rock, you might ask yourself, how did this rock form? Forming hypotheses. Hypotheses are based on observation that has been made. A hypothesis is a possible explanation based on previous knowledge and observation. Perhaps a scientist has observed that thunderstorms happen more often on hot days than on cooler days. Based on these observations, the scientist can make a statement that he or she can test. Warm temperatures can cause thunderstorm. A hypothesis has to be something you can test by using an investigation. A testable hypothesis is a valid hypothesis. Predicting. When you apply a hypothesis or general explanation to a specific situation, you predict something about that situation. First, you must identify which hypothesis fits the situation you are considering. People use predictions to make everyday decisions based on previous observation and experiences. You might form a prediction that if warm temperature cause thunderstorms, then more thunderstorms will occur in summer months than in spring months. Someone could use these predictions to plan when to take a camping trip or when to schedule an outdoor activity. Testing a hypothesis. To test a hypothesis, you need a procedure. A procedure is the plan you follow in your experiments. A procedure tells you what materials to use as well as how and in what order to use them. When you follow a procedure, data are generated that support or do not support the original hypothesis statements. For example, premium gasoline costs more than regular gasoline. Does premium gasoline increase the efficiency or fuel mileage of your family car? Can you decide to test the hypothesis? If premium gasoline is more efficient than it should, then it should increase the fuel mileage of my family car. Then you write the procedure shown in Figure 9 for your experiment and generate the data presented in the table below. A procedure tells you what to do step by step. Procedure: use regular gasoline for 2 weeks. Record the number of kilometers between fill-ups and the amount of gasoline used. Switch to premium gasoline for 2 weeks. Record the number of kilometers between fill-ups and the amount of gasoline used. This data shows that premium gasoline is less effective than regular gasoline in one particular car. It took more gasoline to travel 1 kilometer using premium gasoline than it did to travel 1 kilometer using gasoline. This conclusion does not support the hypothesis. Are all investigations alike? Keep in mind that as you perform investigations in science, that a hypothesis can be tested in many ways. Not every investigation makes use of all the ways that are described on the pages, and not all hypotheses are tested by investigations. Scientists encounter many variations in the methods that are used when they perform experiments. The skills in this handbook are here for you to use and practice. Identifying and manipulating variables and controls. In any experiment, it is important to keep everything the same except for the item you are testing. The one factor you can change is called the independent variable. The factor that changes as a result of the independent variable is called the dependent variable. Always make sure you have only one independent variable. If you allow more than one, you will not know what causes the changes you observe in the dependent variable. Many experiments also have controls, individuals, instances, or experimental subjects for which the independent variable is not changed. You can then compare the test results to the control results. For example, in the foreign village experience, you made everything the same except the type of gasoline that was used, the driver, the type of automobile, and the type of driving that was the same. Throughout in this way, you could be sure that any mileage differences were caused by the type of fuel. The independent variable, the fuel mileage, was the dependent variable. If you could repeat the experiment using several automobiles of the same type on a standard driving track with the same driver, you could make one automobile a control by using regular gasoline over the 4-week period. Collecting data. Whether you are carrying out an investigation or a short observational experiment, you will collect data or information. Scientists collect data accurately as numbers and descriptions and organize it in specific ways. Observing. Scientists observe items and events, then record what they see. When they use only words to describe an observation, it is called qualitative data. For example, a scientist might describe the color, texture, or odor of a substance produced in a chemical reaction. Scientists' observation also can describe how much there is of something. These observations use numbers as well as words. In the description, and they are called quantitative data. For example, if a sample of the element gold is described as being shiny and very dense, the data are clearly qualitative. Quantitative data on this sample of gold might include a mass of 30 gram and a density of 19.3 gram per centimeter cube. Quantitative data often are organized into tables. Then, from information in the table, graphs can be drawn. Graphs can be reviewed. Information that exists in experimental data when you make observations in sciences, you should examine the entire object or situation first. Then look carefully for details. If you're looking at a rock sample, for instance, check the general color, pattern, of the rock before using a handless to examine the small structure. Remember to record accurately everything you see. Scientists try to make careful, accurate observation. When possible, they use instruments such as microscope, metric ruler, graduated cylinders, thermometers, and balancers. Measurements provide numerical data that can be repeated and checked. Sampling. When working with a large numbers of objects or a large population, scientists usually cannot observe or study every one of them. Instead, they use a sample or a portion of the total number to sample. To sample is to make take a small representative portion of the objects or organisms of a population for research by making careful observations or manipulating within a portion or a group. Information is discovered and conclusions are drawn that may apply to the whole population. Estimating. Scientific work also involves estimating. To estimate is to make a judgment about the amount or the number of something without measuring every part of an object or counting every member of a population. Scientists first measure or count the amount or number of a small sample. A chemist, for example, might remove a 10-gram piece of a large rock that is rich in a copper ore. Then the chemist can determine the percentage of copper by mass and multiply that per percentage by the mass of the rock to get an estimate of the total mass of copper in the rock. See Figure 10 for another example. In a 1 meter square frame, positioned on a beach, count along all the pebbles that you can see on the surface. That are longer than 2.5 centimeters. Multiply this number by the area of the beach. This will give you an estimate for the total number of pebbles on that beach. Measuring in SI. The metric system of measurement was developed in 1795. A modern form of the metric system, called the International System or SI, was adopted in 1960. SI provided standard measurements that all scientists around the world can understand. The metric system is convenient because unit sizes vary by a multiple of 10. When changing from the smaller units to larger units, divide by the number of 10. When changing from the larger units to the smaller units, multiply by a multiple of 10. To convert millimeters to centimeters, Divide the millimeters by 10. To convert 30 millimeters to centimeters, divide 30 by 10. 30 millimeters equals 3 centimeters. Prefixes are used to name units. Look at the tables below for some common metric, prefix and their meaning. Do you see how the prefix kilo attached to the unit gram is kilogram or 1000 gram? Now, look at the metric ruler shown in figure 11. The centimeter line are in the long numbered line and the shorter line are in the millimeter line. When using a metric ruler, line up the 0 centimeter mark and with the end of the object being measured and read the number of the units where the object ends. In this instance, it will be 4.5 centimeter. This metric ruler shows centimeter and millimeters division. Liquid volume. In some science activities, you measure liquid. The unit that is used to measure liquid is the liter. A liter has a volume of 1000 centimeter cube. The prefix milli means thousands, 0 per 001. A millimeter is 1000 of 1 liter, and 1 liter has a volume of 1000 millimeter. 1 millimeter of liquid completely fills a cube measuring 1 centimeter on each side. Therefore, 1 millimeter equals 1 centimeter cube. You will use beakers and graduated cylinders to measure liquid to volume. A graduated cylinder, as illustrated in figure 2, is marked from bottom to top in milliliters. This one contains 79 millimeters of a liquid. Mass. Scientists measure mass in grams. You might use a beam balance similar to the one shown in figure 13. The balance has a pan on one side and a set of beam on the other side. Each beam has a rider that slides on the beam. Before you find the mass of an object, slide all the riders back to 0 point. Check the pointer on the right to make sure it swings in an equal distance above and below the 0 point. If the swing is unequal, find and turn the adjusting screw until you have an equal swing. Place an object on the palm, slide the latches along the beam until the pointer drops below 0, then move it back 1 notch. Repeat all the process on each beam until the pointer swings an equal distance above and below the point. Scan the massacre on each beam to find the marks of the object. Move all the rider back to 0 when finished. A triple beam balance is used to determine the mass of an object. You should never place a hot object on the pan or pour your chemical directly onto the pan. Instead, find the mass of a clean container, remove the container from the pan, then place the chemical in the container. Find the marks of the container with the chemicals in it. To find the marks of the chemicals, subtract the marks of the empty containers from the marks filled that the container is filled. Making and using tables. Browse thoroughly your textbooks and your set tables in the text and the activities. In a table, dates or information are arranged so they are easier to understand. Tables help organize and dates you collect during the activities are interpreted. Making tables. To make tables, item is to be compared in the first column. That the characteristics to be compared in the first row. The title should be clearly indicated. That the content of the table and the column or row head should tell the reader what information is found in there. The table below is also collected for recycling on 3 weekly pickup days. The inclusion of kilograms in parentheses is also identified for the reader that figures are mass units. Using tables. How much paper in kilos are you using? How much paper in kilos are you using? And added the figures for all 3 rows. If you answered 32.0, then you know how to locate and use the data provided in the table. Recording data. To be useful, the data you collect must be recorded carefully. Accuracy is key. A well-thought-out experiment include a way to record procedures, observations, and results. Accurately, data can be used one way or the other and minimize the recording result. Set up the table you need, and you need ahead of time so you can record the data right away. Record information properly and neatly. Never put unidentified data on scrap of paper. Instead, data should be written in a notebook like the one in figure 14. Write in pencil so information isn't lost. If your data gets wet at the point in the experiment, record your data and label it. That way, your information will be accurate and you will not have to determine what the figure means when you look at your notes before. Now, it is important to record observations accurately and completely. That is why you always should record observation in your notes immediately as you made them. It is easy to miss details or make mistakes when you record results from memory. Do not include your personal thoughts. When you record your data, record only what you need to observe to eliminate bias. For example, when you record all the time required for 5 students, however, you would not refer to the student time as the worst time of all the message students in the group. You can organize the observation and other data you collect and record in many ways. Making models is on one way to help you better and understand the parts of a structure you have been observing, or in the way a process for which you have been talking. Various measurements works. Models often shows things that are too large, too small, or too normal for viewing. For example, you normally won't see the inside of an atom. However, you can understand this structure of the atom better by making a 3-dimensional model of an atom. The relative size, the position, and the movement of protons, neutrons, and electrons. This can be explained in words. An atom model made of a plastic can in wood clean electron shares that can help you visualize how the parts of the atom relate to each other. Other models can be devised on computers. Some models, such as those that illustrate the chemical combination of different elements, are mechanical and are represented by equations. Making and using graphs. After scientists organize data in tables, they might display the data in a graph that shows the relationship of one variable to another. A graph makes interpretation and analysis of data easier. 3 types of graph are the line graph, the bar graph, and the cycle graph. Line graph. Line graph, like in figure 15, is used to show the relationship between two variables. The variables being compared to go 2 axes of the graph. For data from an experiment, the independent variable always goes on the horizontal axis, called the x-axis. The dependent variable always goes on the vertical axis called the y-axis. After drawing your axis, label each with a scale. Next, plot the data points. A data point is the intersection of the recorded value of the dependent variable for each tested value of the dependent variable after all points are plotted connected with them. Bar graph. Bar graph compare data that do not change continuously. Vertical bars shows the relationship among data. To make a bar graph, set up the y-axis as you did for the line graph. Draw vertical bars or equal side from the x-axis up to the point on the y-axis that represent the value of x. Figure 16. The amount of aluminium collected for recycling during 1 week can be shown as a bar graph or circle graph. Aluminium collected during week 4.0, 3.0, 2.0, 1.0. Circle graph. A circle graph uses a cycle divided into sections to display data as parts, fraction, or percentage of a whole. The size of each section corresponds to the fraction or percentage of the data that the section represents. So, the entire circle represents 100%, 1/2 represents 5.0%, 1/5 represents 20%, and so on. Analyzing the results. To determine the meaning of your observation and investigation results, you need to look for patterns in the data. You can organize your information in several ways. You can organize your information in several ways. Discuss in the handbook. Then you must think critically to determine what the data means. Scientists can use several approaches when they analyze the data they have collected and recorded. Each approach is useful for identifying specific patterns in the data. Remember that when you classify, you are always grouping objects or events for a purpose. For example, classifying rocks can be the first step in identifying them. You might know what obsidian is, a black shiny rock with sharp edges. To find it in large group of rock, You might start with classification scheme mentioned. You locate position within the group of black, sharp edge rocks that you separate from the rest. Pumice could be located by its white color and the fact that many small holes called vesicles. Keep your purpose in mind as you select the features to form groups and subgroups. Observations can be analyzed by noting the similarities and differences between two or more objects. Um, when you look at objects, I'm not sleeping. When you look at objects or events, you see how they are similar. You are comparing them, contrasting, is looking for different objects. The table below compare and contrast the characteristics of two minerals. of two minerals and recognizing cause and events. Have you ever heard a loud pop right before the power went out? Have you before the power went out and then you suggested that an electric transformer probably blew out? Then the event is true. When scientists are unsure of what caused the event, they design controlled experiments to determine what caused it. When interpreting data, the word interpret means to explain the meaning of something and to find out, look at the problem originally being explored in an experiment and figure out what the data show. Identify the control group and the test group so you can see whether or not changes in the independent variable have had an effect. Look for the difference in the dependent variable between the control and test group. These differences you observe can be quantitative, qualitative. You would be able to describe a qualitative difference. You would be able to describe a qualitative difference using only words. Then, whereas you would measure a quantitative difference. For example, if no difference are found between the control and the test group, the variable that is being tested apparently had no effect. For example, I suppose that the 3 beakers each contained 100 millimeters of water. The beakers are placed on plates. And 2 of the hot plates are turned on. But the third is left off for a period of 5 minutes. Then, suppose you are then asked to describe what's any difference in the water in the 3 beaker. Then, a qualitative difference might be appearance of bubble using to the top in the water that is heated, but no rising bubble in the heated water. But then, a qualitative difference might be difference in the amount of water that is present in the beaker. Inferring. Scientists often make inference based on their observation. An inference is an attempt to explain or interpret observation or to indicate a type of conclusion. When making an inference, be certain to use accurate data. Be certain to use accurate data and accurately describe observation. Then, based on everything, explain or interpret what you observe. Drawing conclusion. When scientists have analyzed the data they collected, they proceeded to conclude about what the data mean. The hypothesis formed earlier in the process. Conclusion. To analyze your data, you must review all the observation and measurement. Now that you made and recorded, recheck all data for accuracy. For the after your data are rechecked and organized, you are almost ready to draw a conclusion, such as salt water boils at a higher temperature than fresh water. But then, before you can draw a conclusion, however, you must determine whether the data allow you to come to a conclusion that supports a hypothesis. Now, if your data does not support a hypothesis, as sometimes that will be the case, other times it might not, or that the hypothesis is wrong, it means that the result of the investigation did not support the hypothesis. Did maybe the experiment needs to be redesigned. No, but very likely some of the initial observations was based on incomplete bias. Now, perhaps more observations or research is needed to redefine the hypothesis. Avoiding bias, sometimes drawing a conclusion involves you making a judgment. Now, you form an opinion. Then, you form an opinion about what your data mean. It is important to be honest and to avoid reaching a conclusion. If there is no supporting evidence for it, or if it is based on a couple sample, it is also important not to allow any expectation or result to bias your judgment. Now, if possible, it is a good idea to collect additional data. Scientists do this all the time. For example, the Hubble Space Telescope was sent into space. In April 1990, to provide scientists with clearer view of the universe. Hubble is the size of a school bus and has a 2.4 meter diameter mirror. Hubble helped scientists answer questions about the planet Pluto. Now, the bus has a 2.4 millimeter mirror. Hubble helps scientists answer questions about the planet Pluto. Because for many years, scientists had only been able to hypothesize about the surface of the planet Pluto. Now, Hubble has provided pictures of Pluto. Planet Pluto Planet Pluto is the kind of planet that has celebrated time and time again. This might be the best information about Pluto scientists that will have until they are not able to send a space probe into it. Evaluating other data in conclusion. Sometimes scientists have to use data that did not collect themselves, or they have to rely on observations and conclusions drawn by other researchers. In cases such as these, the data must be evaluated carefully. Did they come up with the same result? Look at the conclusion as well. Would you reach the same conclusion from this result? Then, others, can you believe it? If it is true, and feel comfortable using it. Communicating. The ideas of communication is a part. The idea of communication is that it's not reported. It would advance the scientific community, understanding or knowledge. Communication, communication among the people as a way of improving their investigation. Now, scientists communicate in many ways. That include writing articles in journals and magazines that explains their investigation, as well as a couple of other things. It will advance the knowledge of our heroes past. Scientists communicate in many ways, from writing articles in journals and magazines to experimenting and putting down hypotheses. Scientists communicate in many ways, from writing articles in journals to magazines that explain their investigation and experiments to announcing important discoveries on television and radio to sharing ideas with colleagues on the internet or presenting them as lectures. People who study science rely on computer to record and store data and to analyze results from investigations. Whether you work in a laboratory or just need to write a lab report with tables, good computer skills are a necessity. Using word processor. Suppose your teacher assigned a report. How do you want to write the report? You need to put everything on a piece of paper. When putting them in a piece of paper, the easiest way to do this is to use a word processing unit. Now, on that note, a computer application that allows you to type your information, change it as you will, and do everything as you can is very, very needed. Now, include page numbers and check your spellings. Helpful hints. Helpful hints. If you aren't sure how to do something, your word processing program, look in the help menu. Now, you find a list of topics, check them, click for help, then after you locate the help topic you need, you then follow the step-by-step instructions you see on your screen. Just because you've checked your report doesn't mean that it is spelling imperfect. Always reread your report to make sure you didn't miss any mistakes. Using a database. Imagine you're in the middle of your WhatsApp. Imagine you're in the middle of a research project, busily turning your phone. Before long, you are able to, just as a file cabinet, organize your paper. However, a database, I think I have 30 seconds. I think I have 30 seconds. 30 seconds between each reading. I've been my mouth won't see I finish. Let me rest small between the reading. I want to take short pause in between. All my lips is torn. More, however, a database, why not? More than forever is powerful than a simple file cabinet, because as a click of a mouse, the content can be rescheduled. No. Helpful hints before setting up a database. Sometimes periodically save your database as you enter data. That way, if something happens, such as your computer malfunctions or the power goes off, what you do is simple. What you do is simple. You won't lose all your work. Doing a database search. Use the following search strategies to get reports. Best result there are: place the words and between two of your hands. Also, two words in your search. If you want the database to look for entries, you pray. It would give you information that mentions both Earth and Mars. It is very, very encouraging. Place the word or between two words. At least one of the words, for example, Earth or Mars. Shows entries that have at least one word. Place the words not between words if you want the database If you want the database, you would show your information that mention the moon but does not mention its phases.
And in the year 2024, the responsibility falls on the shoulder of the young girl from Upper Sakoba.
Place the words not between two words. If you want the database to look for entries that mentions